Bonjour, Kim Tu. Welcome. We are talking about the Chateliers Principle. And let me talk a little bit about this simulation. So we have looked at a whole bunch of different, we looked at two different equilibrium systems. Maybe you remember this guy right here, where we were looking at all these different changes. We're trying to explain what happens, why when you put these added stresses to these systems in equilibrium, why they behave the way they do. And so here's how we're going to do it. I've got a simulation right here, which runs old school JavaScript. Woo! So now, what I'm going to do is we're going to look at this reaction here where A reacts with BC in a reversible reaction to form AB plus C. Now notice this is a graph that maybe looks familiar. This is the potential energy, reactants, and products. And I've added, in other words, the temperature is high enough for it to be able to go over this curve. And so what I'm going to do is I'm just going to start with 100 particles of A. I'm going to start with 100 particles of B. All I'm going to do is just click Begin Experiment. And then over here, what you can see happening is a whole bunch of collisions happening. And if I click bar chart here, basically what this is doing is this is tracking the number of particles that at an instant there are in either the reactants and the products. And so, as I can kind of see from this, I can see that my reactants here are generally bigger than my products. Therefore, I can easily make a claim about the equilibrium constant. Is that equilibrium constant going to be greater than, less than, or equal to 1? Well, if the reactants are greater or more prevalent than the products, and you bet your buttons, it's going to have a lower than 1 equilibrium constant. So I'm just going to hit pause here, and we could actually calculate the equilibrium constant in this case, although we're not going to do that at this time. But this is how I can basically think of this, is I can just think of, okay, this is my basic baseline with 100 particles of A and 100 particles of BC that I started with, and this is kind of what it looks like.